Once we have clarified, the basic and the most important concept related to production system, organization, and management, in order to establish the link between management of production activities and the ERP system and SAP in particular, as done with fulfillment and procurement, the first thing to do is to clarify which are the main data that need to be maintained in the system, and then will feed the management of production activities in practice. First of all, let's clarify that this is our unit of analysis, independently for what we saw until now. When we talk about management of production activities in SAP ERP, the process under our scope is this one. So the request for production coming from internal, the production authorization, the management of raw materials for production, the creation of a production order, and the reception of finished goods. So then we will see how to manage activities with SAP ERP, these will be the sub-processes under our analysis. And of course, now that we are going to talk about the data needed to be maintained in the system, we will refer to the data that are needed to manage this type of activities. The organizational data that are relevant for managing production activities are almost all already been discussed in the previous model. So they are client, company code, plant, and storage location. However, in particular, the data which are typical of the production processes are, of course, the plant and the storage location. So let's review very briefly this concept, even if we have already seen that in previous models, so for procurement and fulfillment. Let's start with the plant. The plant is an organizational element that performs multiple functions and which can be relevant to several processes. It can be essentially defined as a facility in which the following functions are performed. So product or service are created, materials are stored and used for distribution, production plan is carried out, and service or maintenance is performed. As you can see depicted here, a plant can be a factory, or can be a warehouse, or can be a regional distribution center, a service center, or even an office. Remember that as a client can have multiple company codes. A company code can contain multiple plants. However, a plant can belong just to one and one only company code. This is instead a storage location. Storage locations are places within a plant where materials are kept until they are needed to be sent to a customer or to the following production phase. A plant can have multiple storage locations, each of which is designated to different purposes. Can be staging area, inspection area, or store specific type of material, like semi-finished goods. Specific storage location can include shelves, bins, cabinets, trays, and can range from small bins, like the one you see depicted here, or entire building, depending on the size of the material being stored. For example, you can see here that storage location for an aircraft is an hangar. So it can be small or larger according to the product that need to be stored. If it is clear, so these are the organizational data that are relevant for the management of production process through SAP ERP. Now we can step to the master data. Of course, almost every type of master data have been already discussed in the first part, because we're talking about the bill of materials, the work center, the product routing, and the production resource tool. We just analyzed this in light of the JBI case and just in order to understand how they are included in SAP. Bill of materials. We already discussed the bill of material concept. A bill of material is a hierarchical representation of the materials which are needed to produce finished goods or semi-finished goods. Bill of material in SAP ERP is defined as single level by definition, but through SAP ERP we can also construct multi-level bill of materials by nesting several single-level bill of material. Here you see an example. The bill of material for a finished good is composed by semi-finished goods, and raw materials. This is one level bill of material. If I want to build a multi-level bill of material, I just have to nest the bill of material of semi-finished good and the bill of material on semi-finished good into the higher level one, and I obtain a multi-level bill of material. The bill of material data in ERP is used for different purposes because it can be used for planning materials for production, defining the production plan, organizing procurement activities, and also allocating cost to product. This is the representation of the bill of material for touring bikes. I mean, I'm going through this very quickly because this is just a representation of the different components that are needed to realize the touring bikes. So we have packaging, warranty documents, brake kit, chain, pedal assembly, handlebar, seat kit, and so on. And for example, for wheel assembly, we have also subcomponents that are needed to realize the wheel assembly. So here we see exactly what we mean by multi-level bill of materials. This is how a bill of material looks like in SAP. As all the documents that we have seen so far, now you should know the drill. Also, the bill of material consists of an header section and an items section. The header section includes data that apply to the entire bill of material, such as the material number, the description of the material, the plan, the usual, the validity, the status, and the base quantity. The materials number in the header identify the finished goods or semi-finished goods that is described then in the bill of material, and the bill of material is valid from the date specified in the header. A validity date is appropriate when changes are planned for a future date, for example, due to the change in the production design. And that's something that I already told you when we talk about bill of material. It's important to maintain the bill of material up to date because the bill of material can be used in several processes. So because of that, the usual field in the header identify the purpose for which the bill of material can be used. For example, the bill of material for the case of JBI, the bill of material for touring bike has a UJAS code of 1, meaning that the bill of material is to be used in production. Other purposes for which the bill of materials can be used are engineering, sales and distribution, and also plant maintenance. Going further, regardless of the specific usage, the bill of material status can be active or inactive. An active bill of material can be used in the production of a material, while an inactive bill of material cannot be used. Finally, we have also the base quantity. The base quantity indicates the quantity of goods that will be produced by the material specified in the bill of material item sections. If we switch to the item section of the bill of materials, we can see that this section identified all the materials that are needed to make the finished good or semi-finished good identified in the header. Example of data that can be put in this section are the material number, are the description, are the quantity, and the item category. In particular, material number and description identified the necessary materials, while the quantity specified how many of these materials are needed. As a bill of materials can contain different types of items, we need to distinguish the item category. In particular, the item category identifies the type of material and influences how the materials is used in the bill of material. We can distinguish different type of categories. A stock item, which is usually indicated with an L acronymous, is a material for which a stock or inventory is maintained, and so a material master should be present. A non-stock item, which is instead listed using an letter, is an item for which inventory is not maintained, so it doesn't need a material master defined. If a material is available in different sizes, such as sheet, metal, or fabric, then different sizes can be represented through the same material number. In these cases, the item category which is used is variable size item, which is usually indicated through R. And data concerning the needed size or dimension must be specified in the bill of material. Finally, a document item, usually indicated in D with D, is used to include documents such as engineering drawing, assembling instruction, and photographs. There are also other type of items, like a text item, indicated with T, which is used to include notes and comment within the bill of material. Or we have also class items indicated with key, which are used in variant bill of material to identify a class or group of items. So they are invariant bill of materials that identify a class or group of items. And we have also what we call intramaterials or phantom items indicated with M, which are a logically grouped set of materials that could collectively be considered as a single material. But I mean, the most important to be remembered are stock item, non-stock item, variable size item, and document items. Then we have the concept of work center. Again, we already talked about work center and their roles in product routings and so on. So a work center is a location where value-added work is executed and specific operation of the product cycle is carried out. A work center, again, can be a machine, a group of machine, an entire production line, a work area, or an assembly area, or whatever. The important is that it should be relevant for the product routing. There are some basic data that are associated to each work center. The basic data section includes the name and the description of the work center and the person or people which are responsible to maintain the master data for the center. And they also identified which task list is used by each work center. Work center data also include default values for operations performed at the work center. Example of default values are control keys, so how an operation or a sub-operation is scheduled, and wage data, so the cost of the workforce. Available capacity instead defines how much work can be performed at the work center during a specific amount of time. So it identifies the available production capacity of the work center. Then a work center is also associated with the cost center, so the container or bucket that accumulates costs that are then allocated through the management by the management accounting processes. This is how a work center looks like in SAP. Again, you will see that there is an header section where general data about the work center are reported, and then you have different tabs where you can see specific data. The specific data that we discussed before are associated to the work center. For example, for the JBI case, we can see that for the Dallas production facility, we have 3 work centers, one for assembly, one for inspection, and one for packing. There are also associated to the Dallas production facility 4 storage locations, RM00, FG00, SF00, and MA00. All 3 work centers are associated with one with one-to-one cost center, the production cost center, and APR 1000. This is the detail of JBI work center. For example, SSY 1000 is the assembly work center. It has 8 hours of labor capacity, and labor is used to complete 3 operations. So stage materials, assemble wheels, and assemble bike frame. So these are the characteristics of this work center, and this is where the cost of this work center are allocated. If you want to analyze another type of work center, we can see INSP 1000, which is the inspection work center. Here the bike is placed on a machine test that inspect the quality of the suspension and the balance of the bike. And essentially the labor capacity is 8 hours, and also the machine capacity is 8 hours per day. So here we have 2 types of resources and 2 different and the same but 2 different nature of production capacity. So one related to the workforce and one related to the machineries. Also in this case, the cost of this work center is allocated to an APR 1000. Then we have the product routing. Again, the product routing is a list of operations that the company must perform to produce a material. Like the bill of material, routing documents include a header that contain data which are applicable to the entire routing, such as the status or the validity of the routing, and then some more details items. In this case, the routing shows 2 sequences, each of which identifies the required operation and the order in which they are performed. In particular, we have sequence 1, which is the standard sequence that goes from operation 1 to operation n, and sequence 2, which is the alternate sequence for the product, which switch the first 2 operations. So it puts before operation 2 and then operation 1. As we discussed before, it is typical to generate alternative routing cycle in order to give some more flexibility and more alternative to the system when product is passing through the production organization. Here you see instead the production routing for GBI's Deluxe touring bike. The routing indicates that operation needed to produce this bike can be performed in only one possible standard sequence from phase 10 to phase 110, and this is the steps that need to be performed in order to realize the touring bike and assembly the touring bike model. As we discussed in the previous section, operations are completed in work center, and there is a relationship between the 2. In particular, this figure shows the relationship between operation 80 test bike and the work center inspection 1000. In particular, it indicates that the setup, machine, and labor time for the operation are 2 minutes for one setup, 5 minutes, and 5 minutes for processing, and so on. And here we can see that in order to perform the operation test bike in this work center, we need to make a setup and pass through a machine, human workforce, and also other type of activities. So this figure show how the routing, so the activities to be performed, cross the work center and which are the main production characteristics of the activities that need to be performed at work center level. More in detail, this figure illustrates the routing for the JBI wheel assembly. So the figure identifies the required operation, so operation number 10, number 20, and number 30, and the work center where the operation will be completed, and the times associated with the operation and the components assigned to each operation. So this is exactly the equivalent of the representation that we saw in the production concept part. So you have a table where operation number, work center, and time and materials and operation are described in detail. In particular, we can see that the wheel assembly has three operations: the stage materials, the assembly components, and the move to storage, all of which are completed in the same work center. So SY1000. And wheels are assembled in batches of lots of 50 units, and it takes 5 minutes to stage the materials for 50 wheels, 3 minutes to assemble each wheel, and another 5 minutes to move the 50 wheels assembled into the storage. As these operations are performed manually, they don't involve any setup time, and we can conclude that the time spent of this operation is essentially labor time, and overall it will take 160 minutes to assemble 50 wheels, which means an average of 3.2 minutes per wheel. And the 160 minutes is determined by this calculation. So 5 minutes plus 3 minutes wheel for 50 wheels plus 5 minutes given this time. If we divide this by 50, we obtain 3.2 minutes per wheel. The final master data, which is relevant to production, is what we call production resource tools. Production resource tools are movable resources that are shared among different work centers. Examples of tools are calibration or measurement instrument, jigs, fixture, documents such as engineering drawings. So are the tools that are needed for production for work center to perform their operation. It is not feasible to replicate or to keep specific tools in every work center because they are not used all the time in the day, so they are shared among different work center, and ERP stored information about these production resource tools in specific master data of the system. Then, to conclude, it is also to deep dive two concepts which are relevant and which are linked to data stored in ERP relating to production system, which are component assignment and production capacity. Let's start with component assignment. The routing indicates how to produce a specific product, while the bill of material indicates which material are used to manufacture that product. There is, of course, a relationship between bill of material and routing, and this relationship is defined via what we call component assignment, a technique that assigns components in the bill of material either to a routing or to a specific operation within a routing. We can see this represented in this figure. This figure presents a component assignment that includes 3 operations in the routing and 3 materials in the bill of materials. Material A is assigned to operation 20, while materials B and C are assigned to operation 30. The right side of the figure instead indicates that the materials are consumed at the beginning of the operations, Any materials that is not explicitly assigned to an operation is instead automatically assigned to the first operation and consumed at the beginning of that operation. So if a component assignment is not defined, a material is assigned to the first operation and at the beginning of this operation. A second important concept to remind is the one of production capacity. In addition to indicating how and from which material finished goods or semi-finished goods are produced, the data contained in bill of material, work center, and routings are used to determine production capacity. Production capacity is a measure of how many units of a product a plant can produce within the given time frame. For example, the JBI Dallas plant can produce 15 bikes or 10 bikes and 15 wheel assemblies per day. Here you can see an example of a production plan for the Dallas plant using a full capacity. According to the fact that every day the Dallas plant can, according to this assumption, so it works for one shift, 8 hours per shift, 5 days per week, 50 weeks per year. It can manufacture 50 bikes per week, 2,500 bikes per year, 100 wheels per week, and 5,000 wheels per year. This is an example of a production plan, so Monday, Tuesday, Wednesday, Thursday, Friday, Monday, Tuesday, and so on. So how many wheels and bikes can be realized each day according to this production capacity. So 50 bikes per week maximum and 100 wheels per week maximum.